following video: simulations analysis by actinoid control. Um, the signal analyzed here was a sinusoidal signal with uh, 5 kilohertz and 20 decibels as an air signal noise to ratio, and sampling time 15 kilohertz and 88 approximately value for decibels for this input signal. The FXLMS algorithms helps to simulate this identification error in order to get the adaptive coefficients, and settling time approximately at 0.05 seconds. And simulations result after to get the control fit adaptive coefficients. It's possible to design these adaptive control algorithms, and was achieved by feed-forward algorithms, and response time was really quickly, approximately at 0.07 seconds. And color blue is the noisy signal, and color red is the anti-noise signal. The difference produced here and reductions of the noisy input value signal. And zoom for the last figure is here. Color red, as is shown, try to get the same value of amplitude of the input signal. For the reasons it reduces the input signal by feed-forward algorithm. The same analysis by feedback algorithm is shown in figure, and some in the response time was 0.5. It's not so quickly, but reduced the noise levels in decibels. The hybrid algorithm has this behavior: response time 0.4 is near faster compared to the last algorithm, and reductions in decibels as showing graphically here. And comparing in this table, feed-forward algorithm, the decrement decibels by simulation was 23.22 and 0.07 in settling time, and feedback was 10.39 and 0.5, and hybrid 16.02 decibels in decrements and 0.4 in settling time. As can be analyzed, hybrid has a overage behavior. Nevertheless, is suggested to use hybrid because of this algorithm has a good response in rejection external disturbance. The experience before this experience was analyzed in other algorithms. Online algorithms was chosen and hybrid algorithm, but the identification process was executed inside the control algorithms in order to get unsettling time approximately 1.2 seconds, but the reductions of noise has a good response compared to the last algorithms. Before to get experience, is necessary understand what is happening between the response obtaining from the loudspeaker, noisy loudspeaker. The sinus signal was analyzed in 0.02, 0.03 and 0.04 amplitude voltage, and the source values for the voltage source is 2 voltage, 3 voltage and 4 voltage was chosen at 3 kilohertz, 1, 2, 3, 4, 5, because of was achieved a good response, not overloading values, and was possible get constructions of the and the noise signal, because this is the response for the loudspeaker. The second loudspeaker is the characteristic behavior for the second loudspeaker or anti-noise loudspeaker. Then the good range operating work is at 3 kHz approximately, and input signal 0.02 voltage as amplitude, and the source voltage should be in 2 voltage. Then the setup explained here: the input signal and measure the signal, goes to the admin, is a controller in real time, process the control and send the anti-noise signal and measure by the error microphones are going back to execute the adaptive algorithm and send to the computer to analyze the data. The algorithm designed here has a reference bibliography by the authors Mr. Chernuchin, Mr. Kuo, Murkan, and Mr. Uwe. And from these algorithms were analyzed as a reference, as a bibliography, designed simulations by Carl Jung, and the reductions in settling time 0.45 seconds, and here is little changes by vibration for external conditions by Least-Mean Square, remember, by identifications. The table shows the identification results. If we remember, the best range of work in 30 kilohertz. It was chosen here. Not the less cases because the second loudspeaker has a good response in this range operated work. And the experimental result by feed-forward algorithm is showing in this figure. Color blue is the noisy signal and color red is the error signal reduced from the noisy signal after the difference with the anti-noise signal. An experimental result is shown in this table was reduced in decrement 8.15 decibels and 0.45 settling time. He's choosing this operating word because it's inside the second loudspeaker operating work. Conclusions: characteristic curve were found to define a range of work. Anti-noise actuator were piezoelectric loudspeaker was analyzed to the operating work. Ventilation systems prototype were used in experience, and feedback feed-forward hybrid algorithms were designed and tested. Suggestions: online model is to identify the system inside acting control algorithm suggested, and the time assigned to execute is Least-Mean Square. Else, online algorithm is executed while user condition is not satisfied. That means online algorithms led to identify the system inside the control loop because of sometimes offline identification process has an other coefficients, adaptive coefficients. For the reasons is a good solutions identify every moment as a condition designed by user to execute these identifications inside the control loop. This product can work in every part of the world because the identification process is as a condition of control. Thank you so much. See you in next videos.